So if you're interested in rasters and pixel block manipulation, this is the right place to be. So please do come a little bit closer if you want to. So I'm not feeling all that lonely up here. We're taking a quick overlook for this one in the demo theater here. Very quick high overview for the Raster API in general, and then quickly go down into how we use and treat the pixels through the pixel block API. So from a very high level point overview, kind of like essentially there are two namespaces if you're dealing with rasters. There's the core data Raster API or namespace that is hosting the classes for raster datasets, pixel block, and cursors. So directly go to the source of the matter. The other namespace is more related to the visualization. So it contains the various type of raster layers, as well as, well, they used to be called renderers. Now they're called colorizers for the raster world. But we'll go directly into the raster namespace, and that's where kind of like the work does happen. So let's go through some definition and look at some code snippets before we actually go through the demo itself. And one thing I would like to, that is kind of like dear and near to my heart, kind of like make the distinction and set up a couple of nomenclatures before we go into it. So the raster data set, that describes the entity that is sitting on a storage medium, either in a file system or in a geodatabase. It is kind of like giving you the name or the properties for the raster data set, is giving you a name and the number of bands. And from there on, you can drill down further because a raster data set has one or more bands. And then from the bands themselves, you get to the mean cell size, the height and width, the pixel type, and so forth. So if you're looking at the pattern on accessing data, be it vector or raster, it's very similar. So we're setting up a connection to our data store, and then on the data store, we're giving the open data set a type, in this case a raster data set by the name, and then we have this raster data set object that we can manipulate. In contrast to that is the raster. So think of the raster as kind of a view of the raster data set. What's being rendered or put into a layer is the view of the underlying data. And the raster itself is kind of like a transient entity. You can change properties on it, height and width. You can change the spatial reference, the extent, without actually modifying the underlying data. So if you are making, we do see that question come up every now and then. You know, I did everything you told me to do, but nothing is happening. Well, if you're doing the operation coming in from the raster layer, you can change anything you would like to, but it doesn't really not affect anything until you make it permanent. So the first line is kind of like we're coming down, kind of like the top-down approach from the layer to the raster. The opposite approach is we're coming up from the raster data set and then instruct the raster data set to give us a raster representation. Going in from the layer, you're making changes to it, is not really affecting it. However, as we see in our example, the other way around, we have the ability to directly manipulate it. So it's important to keep in mind the direction you're addressing this entity. And the raster itself also has some methods on there that allow us the conversion from map coordinates into pixel coordinates and vice versa. Now, what is this pixel block? Well, think of the pixel block as a container that you create in order to get a certain set of pixel values out of your raster. You specify a size and then kind of like think of it as like a bucket. You dip into it and reach out, and so what's in there now, this is the material that you can actually work with. So for each of those planes in the array of pixels that we're getting out of our pixel block, that plane pretty much equates to the number of bands that are in our raster. The pixel block sometimes can get a little bit confusing because essentially just is a generic container for all types of raster data sets and all kind of pixel types. So it can contain anything from 1-bit to 32-bit floating point, unsigned chart, signed charts, whatever we are supporting as the pixel type. So this is something to be aware of. And then the pixel block itself is just the container. In order to get the data in there, we need to read it from the raster. And once we're done with the manipulation, we need to put it back into the raster. So there is a read-write operation required in order to do that. So here in our first line of code, we're essentially sizing our bucket with height and width. And then we're saying, okay, go to this location in the raster, 0, 0, and fill whatever is in the raster and put it into the pixel block so that we can actually retrieve it. Just in case you don't know that yet, raster world starts always on the top left corner and counts X direction or column direction positive to the right and positive down as your row count. Now, there is a little bit of an art of creating the size of the pixel block, or in other words, sometimes you really need to be cautious because that is actually transferred into memory. And every now and then you might run into a situation where you're just dealing with a large satellite image or a large floating point entity. And so the memory requirements can get quite large. And in order to deal with extremely large data sets, we have the raster cursor. So the raster cursor actually chunks up. You can address the whole raster, but it will chunk it up into little entities, little pixel blocks that are then kind of like the cursor is moving you along. So you have control over how much memory is consumed, irregardless of the underlying source. So with the raster approach, you can pretty much deal with any kind of terabyte, petabyte, whatever amount of information you have available, you can go through that. So you can create the raster cursor, the pixel block you create the raster cursor, and you give it an estimate on the height and width of the pixel block sizes that it should produce for you. And then it's pretty much the move next and current approach to iterate through the cursor. Once we get the pixel block, we can manipulate it and then write it back and go ahead and move on to the next pixel block. So with that clarification out of the way, let's look at some code. So here in Pro, we have it's an aerial image for the city of Hamburg, loaded. And in our case, we are kind of like interested in this area for the public swimming pool, and we would like to mask it out. let's say we are throwing a surprise party for a colleague and we just don't want them to know about this area. So what we're trying to do is eliminate this area. So I've created a little tool. We'll sketch the area around it. So once we say, okay, we're done with our sketch, let's go ahead and actually step into the code. So for this one, I'm going ahead and actually coming in through, I'm starting out through the raster layer. I'm getting the data set, the raster data set, and then we go ahead and what we would like to do, actually, we're creating a copy first, because what we're essentially doing to this thing is going to be a destructive operation. And so we're setting up our output, making sure that all the folders exist. And remember when I said whatever we're doing to the raster, or keep in mind that the raster is a transient nature. So this is not the raster that we want to deal with. So we need to create a copy of it first, which means we're sizing and giving instructions to the thing that we would like to create as a copy. But then we actually need to save that raster memory representation and store it out into a physical entity. This physical entity, then we're going ahead, opening up, well, saving it out first. And then we're coming back in from the bottom up through the raster data set. So now we have an entity that we have actually separated from what we see in the display, and that is something now that we can, or that we want to manipulate. So the pixel block that we would actually like to eliminate from the raster data set needs to be positioned somewhere in our raster. We've created that sketch on the screen, but at this point we don't know yet where it is, somewhere in the rows and columns alongside our raster that we have on the display. So at this point we're making the connection or the conversion of the map coordinates into row and column representation of the raster, and the return for those is a tuple essentially. So we have one for the top left corner and one for the lower right corner. Now next we're going ahead, making sure that we have them appropriately sized, and whatever is being returned to us is actually within our raster extent. And so if we're stepping up to this point, now we actually have the width and the height of the pixel block of our area of interest that we would like to manipulate. And so now we go ahead, create our container of the height, width and height. And in this case, I'm dealing with a 3-band image. I just want to mask it out. So we're taking a little bit of a shortcut at this point and saying, okay, we don't really need to fill this pixel block, but let's just make sure that there's nothing in there. So we're doing that 3 times for each of the bands. And now with that emptied raster, with that pixel block, that we're writing back into the location of the top left corner, the size of the pixel block. We're refreshing it, and then adding it back as a new layer into our map. And voila, there's our result. So the area that I've sketched, we essentially cleared out of all the pixels, put it into our copy of the raster, and now added it as a new layer. That's pretty cool. So let's take a different approach and let's actually play maybe with a little bit of the size of a raster. Okay. So I call it the Mystify tool. Essentially what we're doing here, think of it kind of like as a resampling approach. Again, we're coming in from the raster layer and we're clipping out the extent of for our interest and storing that as a separate raster. Now that we bring back, coming in now, starting out at the top, we clip it out and coming back in from the bottom. Now this is the raster that we would like to manipulate. And kind of like the obfuscation is a little bit, essentially it's a resampling kind of exercise. Now what I would like to show with that though is, assume that is an unlimited amount of data. So we're using the create cursor approach. And this one I'm breaking up into chunks of 25 by 25 pixels. So out of the raster, I'm saying, okay, let's create a cursor. And then I'm going through each of those entities that I'm being presented. So we're getting our first pixel block, which is just the container of a given size. For my top left, I'm positioning it to the raster that I'm dealing with, that I had a reference to. And this is where we're filling our pixel block. At this point, we're going through all the bands, or for each of the bands, we're getting the array or the plane of the specific, which equates to the band. And then essentially we're summing it up, all the values, and then we go ahead and compute the average for that one. So the sum of all divided by the number of pixels that are in there. Now here's a little interesting gotcha there that you should be aware of. So the pixel block size or the cursor size, that is a suggestion. Whatever my area is, or the size of the pixel of the copy of the raster dataset that I have created is certainly pretty much, I can guarantee you, is not a multiple of 25 that I have set my pixel size to, or my pixel block size to. So that is a suggestion, but the cursor itself will do the padding or shrinking for you. So as opposed to just dividing by the number, so by 25 by 25 to get the average for my pixel block, the pixel block itself can be dynamic, that is being delivered back to you from the raster cursor. So in order to get the right amount, we're actually paying attention of the size of our pixel block. So in the first case, since we're starting top left corner, it's pretty much guaranteed to be of size 25, 25. But as we're approaching the edges, that will change. So using the cursor, do please pay attention that the returned pixel block is not of a constant size, but will vary on the area of your image. Then essentially what we're doing here is we're going ahead and putting the average value that we have computed back into our pixel for all the pixel blocks, or for everything within our chunk. We're writing that one back into the location. Well, we're doing that for all bands. At this point, we're done with that pixel block. We're putting it back and then go ahead and move to our next chunk. So now we're looping in chunks of, or suggested chunks of 25 through our raster entity. a little bit around 3 seconds. And then we're saying, okay, we're notifying our underlying raster that something has changed. We're cleaning up resources, and now what is being put into the display, we have the pixelated version of the area that we have specified. And this is the original, and this is our obfuscated area. So with that, I'm also recommending tomorrow's session that goes into the Raster API, the renderers in a little bit more detail. 5:30 to 6:30 over in the Santa Rosa room. And it's just going into a little bit more detail, or is covering the layers, the colorizers as in a little bit more detail, which I just pretty much just mentioned in 2 or 3 sentences. And this is the presentation. Any questions? The comment was crystal clear. Thank you very much.